Alrighty, welcome back to maths. Today we're looking at logarithms. In the past, you've probably seen things written with powers or indexes, such as 2 to the power of 3 being equal to 8, but we can rewrite that in an alternate format, whereby you'd have the log of 8 to the base 2 is equal to 3. So it's just a matter of placing these into the right positions as per this format here. What you need to know with logarithm functions is that this value of a, or the base, is all real positive values except for 1. As you can see here, some extra examples here. If you've got 3 to the power of 2 is equal to 8, it's the same as having the log of 9 to the base 3 being equal to 2, and so forth and so forth. Now, when it comes to working out some of these, you could be asked to do these without a calculator. So what we need to do with these is to rearrange them into the other format, and then we can go and evaluate them from there. So we've got the log of 32 to the base 2. Using the information that we had above, this is the same as saying 2 to the power of x is equal to 32. Yep, so that was just using the rule that we discussed before. Remember from previous exercises with indices, if you want to evaluate these, they have to have the same base. So we need to rewrite 32 with the base 2. 32 is the same as 2 to the power of 5. When they've got the same base, we can just evaluate the powers and work out that from there. So x is equal to 5 in this particular case. Next one here, we've got log of 81 to the base 3. Putting it into the indice format, it's the same as saying 3 to the power of x is equal to 81. We're going to rewrite 81 with the base 3. So 81 is the same as 3 to the power of 4. Evaluating the indices here, x is equal to 4. I guess another way you could look at it, if you have this here, they're saying, you could say, what power of 2 gives us 32? Yep, and so we know that obviously it has to be 2 to the power of 5 will give us 32. So that's another way of thinking about this. Yep. Now, the good news is there are some laws regarding the logarithms. They are fairly similar to the index type of laws, so we'll quickly smash through these. So again, you've got the first logarithm law, where it's the product law, where we've got a logarithm of a product is the sum of their logarithms. So here we've got the log of mn to base a. Obviously they're multiplied together. It's the same as the log of m to base a plus the log of n to base a, adding them. Yep. No surprises with the next one, where we're dividing, so logarithm of the quotient. So the log of m divided by n of base a is the same as log m of base a take away log n of base a. So we subtract them in this particular case. This one's pretty cool. Law number 3, the logarithm of power. If you've got log of m to the power of p of base a, what can happen is this power here, the p value, can come down in front of the log. Yep. So again, if you see this like this, that p value can come down in front and be multiplied by the log of m to the base a. It works the other way as well. So again, if you see this here, in this format, that value in front of the log can go into its power there. Yep, so you go between them. Law number 4, logarithm of 1 over m. We know 1 over m is the same as having m on the top line, m to the power of negative 1, which is what they've written here. Building upon this logarithm of power law, if you've got this power here, it's negative 1, that can go in front here. Yep. So negative 1 can go in the front, then you end up with negative 1 log of m to the power of a. Yep. Law number 5 says here, if you've got log of 1 to the base a, it is equal to 0. So again, if you're asking for the log of 1, it's to any base here, it's going to be 0. And also handy to know if you're looking for log of a to the base a, and it's equal to 1. In this particular case, if these values are the same, it's going to equal 1, which is helpful to know. Alright, looking at this example here, it says without using a calculator, simplify the following. Cool, so we're going to apply the log rules that we had just spoken about. Alrighty, so the first thing we've done is writing it out. This one here, we've got the 2 in front of the logarithm here. So remember, this 2 can go back to the power of this 3 here. Yep. So what they've done, they've put the 2 as the power of 3, which is using one of those laws from before. We know 3 to the power of 2 is 3 times 3, which is 9. So that becomes that there. Again, good news is each of these is to the base 10. Yep, so they all have the same base, so we can apply all the laws to this because they have the same base. So we got log of 9 to the base 10 plus log of 16 to the base 10. Remember, when you are adding these, it's the same as multiplying them. So we'll do log of 9 times 16 for these ones, and that's the base 10 because that's adding, it's the product. Here, this one here we're subtracting, and we've got this fraction here. So remember, subtraction means dividing by this fraction. Yep. So they could have written it as 9 times 16 divided by 36 over 25. However, as mathematicians, we should know with fractions, if you're dividing by a fraction, it's the same as multiplying by flipping that fraction upside down. So what they've done here is, rather than saying divide by 36 over 25, they've written it as multiplying by the 25 over the 36. So flip that fraction upside down. From here, they've actually run the calculation, and it is 100. So we've got log of 100 to the base 10. And again, we need to do this with our calculator. So we're really saying, okay, well, what does 10 need to be raised to the power of to make 100? And you should know that it would be 10 to the power of 2. 10 times 10 is what gives you the 100. The answer here is 2. Next ones I want to chat about. It says here, solve each of the following equations for x. We've got log of x to the base 5 is equal to 3. Cool. So again, the whole idea is to change the format. So this here is the same as saying x is equal to 5 to the power of 3. That's just changing it to that format. Obviously, now we can work out what x is. Yep, it's just 5 to the power of 3. 5 times 5 is 25, times 5 is 125. This one here, we've got log of 2x plus 1 to the base 5 is equal to 2. Again, it's just a matter of changing that format. So we know it's this part here, the 2x plus 1, is equal to 5 to the power of 2. Yep. So the first step is to change the format that we discussed at the start. And then we can evaluate and work out or solve what x is. We've got 5 to the power of 2 on the right hand side, that's 25. Obviously subtracting 1 from both sides, we've got 24 here. And then we need to divide both sides by 2, we get x equals 12. Okay. Once you get it into this format, relatively straightforward to go and solve it from there. This one here, what we're going to do first of all is apply some of the log laws. Where you have the same base and we're subtracting, obviously we know it's like going to be the quotient sort of rule for the logarithms. Yep. So it's going to be this one here divided by x take away 1. It's the same as writing it. Yep. Given we've now got this here, we're going to use, or we're going to change the format. Okay. So remember, it's this part here, 2x take plus 1 divided by x take away 1. So what you're finding the log of is equal to this here, the base, to the power of that there. So It's just changing the format again. Once you've done that process, it's a matter of solving the equation. We've got this 2 to the power of 4 is 16. You've got x take away 1 on the bottom line here. It's been divided. So we're going to times or multiply both sides by x take away 1. That goes over to this side. From there, it's a matter of expanding things out, rearranging things, and you'll get x being equal to 17 over 14. Last but not least, we've got this here. Okay, we're adding, which means we've got the product rule. We're going to be multiplying these by each other. Yep. So we're going to have the log of these multiplied by each other to the base 3 being equal to 1. Now, again, what you should notice is if you have x take away 1 in one brackets, x plus 1 in the other brackets, this is a difference of perfect squares. It simplifies down to the x squared take away the 1 squared. Yep. X squared take away 1 squared. 1 squared is just the same as 1. Yep. So that's how that expands out or simplifies down there. Once you've got that there, changing the format, it's this here, the x squared take away 1 is equal to the 3 to the power of 1. Yep. 3 to the power of 1 is just this 3 that's here. Yep. Rearranging things, adding 1 there, square root of that, it's going to be plus or minus 2 is the answer. Now, when you go back to the original question here, because we're dealing with logarithms, we're not looking at the negative values here, so we're going to disregard x being equal to -2. We're just looking at the solution being x equals +2. Thank you very much for listening up. Bye for now.